Good morning or greetings, depending on where you are. So for today, I want us to look at how to multiply to 8-bit numbers. In this case, we are going to multiply 5 by 3. Now, something that you need to note is that we don't have a multiplication instruction in the 8085 microprocessor. So what we do is that we continuously add two numbers until to the point where we get our desired result. Simply put, for instance, in this case, let's say we have an example. We want to multiply 5 by 3, okay, so that we can get our 15, right? So what we are going to do is that we are going to continuously add 5 3 times so that we can have 15. Okay, so we are going to have 5 plus 5 and plus 5. Okay, so that is what we are going to do in this case. So simply, this is going to be our code, our assembly code in this case, and we are going to use two memory locations to hold our values. Okay, we are going to use 3000 and 3001. Okay, then we are going to additionally use the subsequent two to hold our result, as well as to hold any carry that may be experienced as we do our arithmetic in this case. So to start us off, maybe we can just scrutinize the code and how it is. As you'd expect, at some point we are going to have a loop. Okay, so maybe the gist of the entire code is somewhere here, starting from line number 9 all the way to 13. Maybe that's where maybe most of the things will be highlighted. But then maybe we can start by highlighting the first line, that in this case number 4, line number 4, right, where we talk about load immediate H with 3000 or 3000. Now, something that to note in this case is we are talking about a load immediate, which means whatever data is on the right hand side after the comma will be directly put in this register. Okay, so in this case, we are actually going to load this address, not the content in this case, which is 3. No, we are going to load this address into this register. And remember, to load an address, you require a 16-bit size register, which then again brings us to this particular mnemonic that we have here. Whenever you see X, okay, X tends to illustrate that we are talking about a 16-bit register, or simply put, we are talking about a register pair. So when I put, or whenever you see a code in any of these ones that we have in this 8085 microprocessor, whenever you see X, okay, within the code, we tend to highlight register pairs. So for instance, this one where there is an X, and then this other one as well. So in this case, we are not only talking about H, we are talking about the register pair HL. Okay, so when we say load immediate H, we actually mean we are loading immediate in the register pair HL. So we are going to do that, and then the other thing to remember is that we are actually loading the address itself into that register pair. So that is what we are going to be doing. And simply put, maybe I can have this illustration here so that we can highlight all the registers and maybe the memory that you're going to be using. So in this case, we've said that in the HL register, we've just loaded the address 3000. So that is what will be found inside the HL register. Then go to the next line, which is line number 5, where we say move, okay, whatever is inside the memory now. Okay, so when we talk about the memory, we are referencing the memory referred up here. So the contents of that memory was 3. So in this case, we are talking about whatever is inside the memory, we put it into the register D, in the register D. So what that means is this, that we are going to have our memory having 3. Okay, it already has 3, and that 3 we are putting it inside the register D. Okay, so that is what line number 5 means. Then line number 6 talks about move immediate. Okay, so it's similar to whatever we had in line number 4, but now we are only talking about one register. Okay, in this case the accumulator, and we are saying move immediate 00. Okay, so what that means is we are taking this actual content, this actual data, and putting it inside this register. So in this case, this is just 0, and that is what we are going to have in the accumulator. Simply put, we are just initializing the accumulator. Okay, we've just initialized the accumulator. Then we go to line number 7, which talks about move in this case, not move immediate, move the contents of sorry, register A into register E. So what this means is we are just loading register E with 0. It's just another way of initializing. You can also as well just move immediate E with 00. Still works because you're just trying to initialize. Now, to be said, this register E, for this case in our logic, what it is meant to do is it's supposed to hold our carry. Okay, it's meant to hold our carry. Then this one is meant to hold the other number. Okay, in this case we want to multiply 5 times 3, so this one is going to be holding 3, and we are going to continuously decrement it at the point where we get to 0. And then you're going to see next we are going to increment the register pair HL so that we can move on now to the next value. Okay, so and that is what we have in the next line where we talk about increment. Okay, and this increment has an X, which means it's not only incrementing register H but also the register pair HL. So in this case we are going to increment the register pair HL, so which means incrementing means we are adding by 1. So this is going to be 3 0 0 1. Okay, so after moving to this, it means that when now we are talking about a memory, we are talking about our memory. The memory in this case being referenced is now the new 3001. So which means our memory now will be referencing 5. Okay, now we'll be referencing 5 because that is what we have based on whatever we've been able to show by this trend. Okay, we've already now moved on to the next register, to the next address. So when we talk about the memory, we now reference this memory here. So it now has 5 because that is what we loaded inside that memory to start us off with. So after that, the next line talks about continue. So this one we are going to see its purpose. It's meant to be used inside this loop, so forget about that one for now. But then we are talking about add m. So what this means is this memory, which has 5, we want to add its content to the accumulator. So we add 5 to the accumulator. So it's 0 plus 5, so that gives us 5 there. And then the next line, we read it as jump on no carry to skip. So what this means is if there is no carry after adding, okay, which in this case there is no carry after adding, then we are supposed to skip the next line, which is line number 11, and go to the next line that has this skip, this keyword skip, and the words keyword skip is at line number 12. So when we say jump on no carry to skip, it means we are skipping to this one or jumping to this one. Let me put it that way. We are skipping to line number 12. So when we go to line number 12, it says we decrement D. Decrement D, that is what this means. DCRD, it means decrement. Decrement means subtracting 1. So when we decrement D, in this case D, remember, has 3, we are going to have 2. Okay, and on having 2 there, we are then going to go to the next line, which talks about jump on no 0 to count, jump on no 0 to continue, right? So in this case we are having we are jumping to this one. You remember this CONT that we saw before? That's where we are going. Okay, that's where we want to go back to. Okay, so we want to go back from here all the way to here, to line number 9, because we've said that jump on no 0 to COT. And on what this means, jump on no 0, is it's referencing this decrement of D. Okay, so because D has been decremented and it's not yet at 0, that's why we are going back to line number 9. So in this case we are going to go back to line number 9 and then repeat the same process again. So we add m is still 5, so we add m to the accumulator. So we have 5 and we have 5, so now it's going to become 10. Okay, and on having 10, we go to the next line. The next line says jump on no carry to skip. So we still don't have any carry. There is no carry over. So in that case, we skip line number 11 and we go to skip, which is line number 12, and we decrement D again. So we decrement D in this case, which becomes 1, and then we check, has D gone to 0? No. So which means we are going to jump on no 0 to CONT to continue here. Then again we repeat the same process again. We add 5 again, which gets to 5, which gives us 15, and then we skip because it hasn't been a carry, there is no carry, and then we decrement D again. So now we decrement D and it becomes 0. Okay, now we go to the next line, which says that we are supposed to go back here if D is not 0, but now in this case the condition has been met, so D is actually 0. So now we move on to the next line, which is line number 14, which says, okay, store the accumulator. So whatever is inside the accumulator, we store in this memory address, which is 3002, and that's where we put this 15. Okay, and then after that we move whatever is inside E, which is supposed to be our carry, which is 0. In this case there was no carry. We put inside the memory location 3003. That is what store the accumulator is now, and that's what we have there. And then at the end we just hold. So it's a simple program where we've multiplied two numbers by continuously adding a number until a certain condition has been met, where the other number has decremented all the way to 0. Now subsequently also division is done in a similar fashion, but now in this case it's subtraction. We'll be able to see that one in the next video. Thank you for watching.